Today we will discuss numericals on motion of electron in both electric and magnetic field. For that we will discuss some of the formulas. The first one is when an electron or a proton or any charged particle is accelerated through some potential or potential difference B, then the kinetic energy developed in the charged particle is given by EV, or half mv square is equal to EV. Small b is the velocity of the charged particle developed, and capital B is the potential difference provided or to the charged particle for acceleration. M is the mass of the charged particle. The second case, when a charged particle, either electron or proton, is kept in a electric field E, then the force developed on the charged particle is charge into electric field, or F is equal to EE. For electron and proton the charge is E, so force is EE. Similarly, when an electron or proton or some charged particle is kept in a magnetic field, then magnetic field is generated by B, then force on the charged particle is given by BQV sin theta, and if it is proton or electron, then the force will be equal to BEV sin theta. Now if the charged particle enters into the magnetic field perpendicularly, then theta will be equal to 90, and if theta is equal to 90, then force on the charged particle will be PEV. This force is perpendicular to both magnetic field and velocity of the charged particle. Because of this, the charged particle will have circular path. You can see in the figure, the cross denotes the region where magnetic field is applied. This field is perpendicular to the plane of the screen. When a charged particle enters into the field perpendicularly, then the force on the charged particle will be perpendicular to both the velocity and magnetic field, so it will trace out a circular path, and the centripetal force required for the circular path of the charged particle is provided by the force BEV. So BEV is equal to centripetal force. This equation can be used to obtain the radius of the circular path formed. Now we will use these concepts to determine to solve some numericals related to this topic. Here is the first question. Calculate the radius of a water drop which would just remain suspended in an electric field of 300 volt per cm when charged with 1 electron. So we have a water drop in an electric field. So consider two plates between which there is electric field whose value is 300 volt per cm. this is equal to 300 volt by 1 by 100 meter, that is 30000 volt per meter. And the charge on the water drop is equal to 1 electron, that means 1 E, that is 1.6 into 10 power minus 19 coulomb. Now when a charged particle is in the electric field, the force due to electric field is upward, given by QE, and the weight of the charged particle or water drop is downward, mg. And since the question says that the water drop remains suspended, in this condition the upward force and the downward force will be equal. So when we apply the condition, QE is equal to mg. Now putting these values, we get 1.6 into 10 power minus 19 into 30,000 is equal to m into we take the value of g as 10. So this comes to be mass of the water drop as 4.8 into 10 power minus 16. But we need to calculate the radius of the water drop. So we know that mass is written as density into volume. Since water drop is spherical in shape, so volume will be 4 by 3 pi r cube, and density of water is 1000. Now substituting all the values, we get r cube is equal to 1.145 into 10 power minus 19. Therefore r is equal to cube root of 1.145 into 10 power minus 19 is equal to 4.85 into 10 power minus 7 meter, which is the required answer. Now we have the second question. An electron beam is accelerated by a potential difference of 300 volt and then enters normally a magnetic field of 10 power minus 3 Tesla. Calculate the velocity reached by the electron and the radius of its path in the magnetic field. So here first we will use the concept electron beam is accelerated by a potential difference of 300 volt. Then kinetic energy of the electron beam will be equal to EV 1 by 2. Mass of the electron is 9.1 into 10 power minus 31 into v square. Small b is the velocity of the electron beam, and capital B is the potential applied. Charge of the electron 1.6 10 power minus 19 into potential 300. So from this we can calculate b square as 1.054 into 10 power 14. Therefore b is equal to 1.02 into 10 power 7 meter per second. Now according to the question, this moving electron enters normally into the magnetic field of 10 power minus 3 Tesla. So what will be the radius of the path? As we know that if charged particle enters normally in the magnetic field, the path of the charged particle will be circular. So the radius of the path is given by mb by be. Mass of the electron is 9.1 10 power minus 31. Velocity is obtained as 1.2 10 power 7 magnetic field applied is 10 power minus 3 and charge of the particle is 1.6 10 power minus 19. So putting all this value and calculating, we get R as 0.058 meter. These are the required answer. Now here is the another question. A 10 electron volt electron is circulating in a plane at right angle to a uniform field of flux density 10 into 10 power minus 4 Tesla. What is the period of revolution? So here given the kinetic energy of the electron is 10 electron volt, or half mv square is 10 into 1.6 into 10 power minus 19 joule of energy. We put the values for electron mass is 9.1 into 10 power minus 31 into b square is equal to 10 into 1.6 into 10 power minus 19. Therefore or b square is given by 3.51 into 516 into 10 power 12. Therefore b is equal to 1.875 into 10 power 7 meter per second. Sorry, this one is 1.875 into 10 power 6 meter per second. Now when this electron enters into a magnetic field at right angle, then the radius of the path is mv by be, which is equal to 9.1 into 10 power minus 31 into 1.875 into 10 power 6 by applied magnetic field is 10 into 10 power minus 4 and charge of electron 1.6 into 10 minus 19. This gives the value 1.066 into 10 power minus 3 meter. Now time period for revolution is given by circumference of the circular path by velocity. This is 2 into 3.1415 into 1.066 10 power minus 3 by 1.875 into 10 power 6. This gives the value 3.573 into 10 power minus 9 second, which is the required answer. Here the another question is, a proton at rest is accelerated through a potential difference of 2.5 into 10 power 5 volt. It then enters a uniform magnetic field perpendicular to the field lines. If the flux density of the magnetic field is 0.5 Tesla, find the radius of the circle in which the proton travels. So here first, since the charged particle is accelerated through a potential difference, then kinetic energy of the charged particle is given by EV, and here the case is proton. Mass of proton is 1.6 into 10 power minus 27 b square. B, small b is the velocity. E 1.6 10 power minus 19. Capital V is potential applied 2.5 into 10 power 5. So b square comes to be 5 into 10 power 13. Therefore velocity of the proton will be 7.07 into 10 power 6 meter per second. Now this moving proton enters into the magnetic field perpendicularly, so the radius of the charged particle proton in the magnetic field is given by mv by be, that is 1.6 into 10 power minus 27 into velocity comes to be 7.07 10 power 6 by applied magnetic field 0.5 Tesla, and charge of the proton is 1.6 10 power minus 19. This comes to be 0.1414 meter, which is the required answer.